Hey guys, how's it going? You're about to watch a video on 10.3, Arcs and Chords Part 2. In this video, there's only one theorem that we're going to take a look at, and then we're going to try a few example problems about this theorem. The theorem says that if you have the same circle, or if you have two congruent circles, the chords in the circle, if you take any two chords, they're going to be congruent if, and only if, they are the same distance from the center. So in this picture that we have here, look at this chord FG and look at the chord JH. Those two chords are congruent, they're the same length, if this distance here is the same as this distance here, because this is the center of the circle. Now, of course, there are lots of different lines that you could draw from the center of the circle to the different chords. I could have drawn a line like this or like this, and of course those lines are all different lengths. So we have to say that when we measure the distance from the point L, which is the center, to the chord, we're going to make sure that that line is perpendicular because that's going to be the shortest distance. So if this distance and this distance are the same, then this chord here, FG, is congruent to this chord here, JH. That's what our theorem says, theorem 10.5. Let's go ahead and take a look at an example problem. All right, in this problem here, they're telling us that in circle A, WX is equal to XY, and those are 22. So they've told us that the chords are congruent. So therefore, because the chords are congruent, we know that the distance from the center of the circle to each chord is also congruent. So we can say 5x is equal to 3x plus 4. Then we can subtract 3x on both sides, and then we can divide by 2, and we get that x is equal to 2. Now they wanted us to find AB. AB is 5x, so we would say 5 times 2 is equal to 10. So the length of AB is 10. All right, here's an example problem for you guys to try, which is pretty similar to this one. Go ahead and pause the video here, give this problem a try, and then you can check your answer. Okay, so we know that the distance from the center to each chord is the same because it's both labeled as 8. So therefore we know that chord QP is congruent to chord RS. So PQ is going to be 3x minus 4, and that's equal to RS, which is 14. Now we can solve it and find out what x is. Looks like we're going to end up getting a fraction here. That is okay. I'm just going to leave it as 18 thirds. That's what x is equal to, is 18 thirds. Guys, that's pretty much it for this lesson. We do have a few more problems to do, but they're going to be review problems. They are review from what you did in the last video, and there's also one problem thrown in there from today. So go ahead and take a look at these review problems here. If you can solve these 4 problems, you are good to go with section 10.3, Arcs and Chords. Go ahead and pause the video, see if you can solve these 4 problems, and then I'm going to show you the answer. And these are the last 4 problems in this entire video. So go ahead, take as much time as you need, work on the problems, and then you can check your answer. Alright guys, so these are the answers for these 4 problems. If you want to see how to do them, go ahead and keep watching the video because I'm going to explain them all right now. Alright, let's take a look at these problems here. We have the first one, number 8, find the value of x degrees. Well, looking at the picture, I noticed that FG is congruent to HJ. So if the measure of arc GF is 70, the measure of arc HJ is also 70 degrees, which means that the measure of angle X is 70 degrees. So the answer for number 8 is 70 degrees. Now, if you're not sure, you can also kind of ask yourself, well, does that make sense with the way that the picture looks? It does, because I know 90 degrees is going to be like a 90-degree angle like that. So 70 degrees, it makes sense. All right, number 16 and 17. We've got the circle here. The radius is 14, so that means AB, that's the radius, that's 14. And then CD is 22. Now because AB is a perpendicular line here and it's a radius, we know that it bisects CD. So this is 11 and this is 11. So they want us to first find CE. Oh, I just did that. CE is 11. And they also want us to find EB. All right, I'm going to draw a triangle in order to find EB. Let's draw it like this. Okay, so in that triangle that we've just drawn, this is the A, the C, and the E. We found out that this is 11. Now AC is also what in the circle? AC is a radius, and the radius is 14. And because this is perpendicular here, we can use the Pythagorean theorem to find out what x is. Let's see, I'm going to say x squared plus 11 squared is equal to 14 squared. So x squared plus 121 is equal to 196, and then when you subtract 121 from both sides, you get x squared equals 75, and then you can take the square root of 75, and that equals 8.66, and they told us to round it to the nearest hundredth, so 8.66. That's not the length of EB though, that's the length of AE. So AB was the full radius, so the full radius was 14. So to find EB, we have to do 14 minus 8.66, and that equals 5.34. So 5.34, that is the length of EB, is 5.34. All right, and the last one here, number 22. In circle F, AB is congruent to BC, DF is 3x minus 7, FE is x plus 9. What is x? All right, so we know that DF is going to be congruent to FE. So we can say 3x minus 7 equals x plus 9. And then we solve it for x. And we get that x is equal to 8. All right, guys, that's it for the day. Go ahead and submit your notes on Canvas, and then you are good to go. Have a great day.